Hey guys, Adam Beck here. So today we're going to go over a very basic intro and kind of scripter's perspective on Unity game engine. And I will say this about Unity: it is a very lightweight engine, right? So it's mainly meant for mobile games, and it's meant to not run a lot of the fancy features like screen space reflections or dynamically occluded objects based off grid locking. There's a lot of more advanced stuff like Lumberyard and Unreal and Havoc engines have, but Unity is great. And the reason why I work with it mainly is it's free, right? So that's kind of a big incentive. And secondly, you can really adapt things on the fly much easier than it would be to build things in like Unreal. And I have tried Unreal. It's complicated, right? So it has a lot steeper of a learning curve. Unity here is great because it's lightweight. You get to play around. You get to see how your scripting is really going to affect the game, and that's why I always do this, because it's free and easy, and that's why I recommend it, especially for beginners. Which I am. So you can go to the website here, unity3.com. Googling it works perfectly. Go ahead and click Get Unity. We're just going to install it real quick. They do have Plus and Pro. This is not for the personal user. As you can see, it's a personal option, right? This is for like businesses. This is for teams. This is for actual game development, like studios. We are personal. Unless you're starting your own studio, don't bother with them worrying about what that stuff all means. Alright, you just gotta click confirm, make sure you're not doing any of these things. You can't earn money, you cannot be using Plus or Pro, and then just download. And it's gonna take a little bit to download, right? Because the exe is gonna download, and that's small itself, but it's actually going to go ahead and download the whole rest of the engine. So it's gonna take a while, and then it's also going to install Visual Studio, and I'll go and do it real quick to kind of show you. Right, let's get started. You download it, put it download, save, open it, see how fast that was. And once you've confirmed the yes, you want it to make system changes, it'll eventually show up. It may not. There you go. Let's wait for it. Cool. So you click next as usual. It's going to connect to online. It's going to get the current terms. Read it if you feel like. You're a whole level higher than I am if you do. Right. You accept it. Next. And there will be another option here, right? I just have Unity in documentation, but there'll be a third option that says Microsoft Visual Studio. You want that, all right? You're gonna want it, and you can use older versions, but you get a free access 2017. I mean, it's just a community version, so it's free. So go ahead and download that. It'll tell you how much space you need, and then click next, and it'll start to download. And then you'll see Unity will finish downloading. Then it'll open up Visual Studio. That will finish downloading. And then once you're done there, you'll have Unity open. And if you think you're going to be using Unity a little more than normal, like you're going to be making several, like you're going to be working and you're going to be making projects, you actually want to be a little more long term here, Unity Hub, which is on the website as well, go ahead and find it real quick for you. Right, try personal, and there's Unity Hub, same right next to it. And Unity Hub isn't like any better, it's just this hub, like as I named it, for you to manage what version you're playing with, right? So it's a good way to be like, oh, well, I'd like to uninstall this one and install the newest one. You can see I have the newest one installed here. So it's a good way to keep updated, that way you don't have to keep going to the website and trying to find it. So this is a good thing there. You can see which ones are installed, where they're installed, all that good stuff. Better releases, careful of that. You don't really worry about anything like that. Too complicated, right? You don't need to get into the development cycle. But anyways, you will see something along projects, and you'll see an option for a new project. And this is what we're going to be doing. You're going to click new, and you're going to see something very similar to mine. It's not going to be very different at all. And we're going to be doing actually something very similar to one of Unity's first tutorials, right? So the first one they make is Rollball. And you can find the tutorials just by Googling them. Pretty easy. You can get them from our website as well. It's very easy. Right, learn tutorials. And there's this Rollball one. You can see it's beginner, right? So And they have tons of tutorials. So if this is a little too slow for you, go ahead and do one of the more advanced ones. I've done this one, I've done that one, I've even done this one, right? And I've definitely done rollball. That was the first one I ever did. And there's some really interesting ones here. And you don't have to know how to model, how to texture, anything like that. Just like if this video isn't good enough for you, you just want more explanation, go to them. I mean, they're the ones that created it. Let them do it. And there's some cool stuff in here. Like, there's more advanced stuff, procedural cape generation. There's some really cool things you can do with Unity. We're gonna do something very basic, rollball tutorial, because we're not approaching this as artists. We're not approaching this as a studio. We're not approaching this as game developers. We're approaching this as people who are trying to learn scripting in many different environments and trying to learn how we can kind of help or better the world around us or develop ourselves professionally. So we're going to do that. You can see it's very small, very easy to do. So that's what we're going to be kind of following. We're going to do it slightly different, not exactly the same. And so just go and give it a name, rolling ball. You can name it whatever you feel like. There is templates. These preview ones are extra stuff that Unity is trying to work with right now, like different rendering pipelines. So you don't really need to worry about that. And we're not going to do 2D. It is easy. It's not any harder than 3D. In fact, some would consider 3D harder. But what we're doing is very basic. We're just doing 3D. You can choose a location. Mine's on my D drive, right? Unity projects. You can just click this to choose. There you go. See? And then Unity Analytics. This is going to send them data about your project to kind of just collate data, right? They're trying to, a lot of businesses like to get data about their users. You can turn that off. You may need to create an account, by the way, when you set up this, and it may ask you, like what country you're in, are you sure you're not using it for business, how much money are you going to make off of this, etc. Just go and answer that stuff. They need to do it for like this little survey thing. Just get past it. It's all free. Don't worry about it. And then once you get here, fill out this stuff. Pretty simple. And then we do not need asset packages, right? We don't need this. This is not, no. We don't need that stuff. And create. And it'll go through creating up the basic project, create necessary files and whatnot, and it'll open up the editor. And so I just want to forewarn you and say that, there can be a lot of complex stuff in this. There can be a lot of menus, there can be a lot of stuff, but we're going to approach this as if we've never seen it before, and so we're going to gloss over a lot of stuff just to make sure that the very basics are covered. That way, if you were to install this, you yourself can just simply just pull this up and start playing around, start scripting. That's the important part here, scripting, scripting, scripting. So I'm going to give you a brief UI overview here. This big middle one, that's our game view, right? This is how we see our game and what's in the scene. What you're seeing around us is a skybox. This is rendered behind everything in the scene. This is always there, and you can change it if you want, but we don't need to get into that today. This icon here looks like a sun. Well, that's exactly what it is. It's a directional light, right? And it's just shining light down. And we'll see how that actually interacts with objects here in a second. The only other object you see in here is the camera, and that's actually what our game view sees. So we have another tab up here for game view. This is exactly what that camera is looking at. You can see the preview down here. All right. So how do I move around in here? How am I doing this? I'm holding down right click, and that lets me just look around on the spot. Just look like moving your head around. And then while I'm holding it down, I can use WASD to kind of fly around in whatever direction I'm looking. And that gives you a really nice kind of control over where you're looking, what you're looking at, etc. If you ever get super lost in your scene, right, just click one of these, anything you have in your scene, and press the F key, and you'll see it focus on that object. And that's a good way to kind of bring your perspective back down and kind of reorientate yourself back in. Holding down left click, you can like drag select things. Right, so if you want to do multiple items, you can do that, just like most applications. Scroll wheel can do that. And I believe if you hold, there you go, if you hold right alt, or I'm sorry, left alt, right alt may work too, and hold right click, you can move in and out to zoom. Right, let go alt, there you go, see, still zooming. And then naturally, once you press alt, see if you, okay, so you hold alt and then right click, you can zoom, okay? And then if you right click and then alt, it doesn't really do anything. So alt first, then right click, right? If you're holding alt and then you press left click, you orbit around your focus point. So you can definitely get some different types of maneuverability with your camera. Just keep in mind, the scene camera is not the same thing as your game camera. This is your game camera. You can't move this around. In fact, it's kind of zoomed out. Let me fix that there. Okay, so you have these two different tabs, and you can actually move around things in the editor. So like you can pick this up and just dock it, and you can have them run side by side just like that. Say, scene view and your game view. So that's the thing. You usually keep it like that. This is like the default layout, right? So, what's in the scene? All right, we talked about the camera, we talked about the sun. Now, you can see over here these highlight as I click them, right? So this menu, this hierarchy view, is how you see everything in your scene. For example, if you right-click and you go to Create, kind of like down here, 3D Object, in just a basic cube, you'll see it show up right there, and bam, you see a cube in your scene. Now, I'm just going to do something real quick. We're going to get into this in a second. I'm going to put it back onto 0, 0, 0 in the world, right in the center point. Okay, you can see our cube over here. You can rename objects by clicking on it and then clicking on it again, Solure, not double clicking, and renaming it. So this is, I don't know, center cube, because it's in the center of the world, right? Which brings me to the next point. Okay, up here we have some tools, right? This hand is just for camera navigation, just for looking around. You can't click objects, see? I can't click my sun, I can't click the camera anymore, so it's just for looking around. This one, the little arrows, you see arrows pop up when whatever object is selected here. This allows you to move stuff around, see? You can drag along the x-axis, the z-axis, and the y-axis. Control Z does undo your actions, and so that gives you control over the position. If you switch over to rotate, you can rotate along the x, z, and y. Right? If you do it in the middle here where it gets kind of darker, you can just free rotate. Okay? This one that we're really concerned with, we're not going to touch these last two. That's for 2D sprite stuff. We're dealing with 3D objects. This last one is scale. And this effectively just kind of warps our object to whatever kind of size that we want. It's no longer a cube, it's more of a rectangular prism at this point. So that's kind of how you can make a wall or a floor. There's a little bit better ways of doing that, and I'll show you that here in a second. And you can rotate it and do whatever you do. Like, here we go. Let's get a wall. It's pretty close to a wall, right? Okay. So I'm going to go ahead and delete this. What we're going to do is we're going to bring in a 3D object and a plane, right? So there's a plane. And a plane, let me reset it. So if your object is off like this, we know the center's right there, but it's off. It's like it's below here. On the right here, under transform, there is a position. You can see the position. You can see it's not 0. So just go and type 0, tab, 0, tab, 0, tab. Another way to do that is clicking this gear icon and clicking reset. Okay, that'll put to 0, 0, 0. So a plane is good because it has no thickness. It's just, if we go into wireframe, we can show you the meshes here, the mesh. You can see it's just like an array almost of vertices and triangles, right? So it's very lightweight on the rendering system. And if you go below it, you'll see it's invisible. What this means is, in a rendering platform, the back face of vertices, like the backside, is not visible. It's actually invisible. It only draws the front side. And there's actually performance reasons to this and other calculations that we don't need to get into. But yeah, so if you see it, it's invisible, but you see the outline, just try going to the other side. It's probably on the other side. So yeah, you can see our plane over here now. Down here, you'll see our console. This is where any error messages, info messages, anything we print to the console, etc. will show up. There's a couple settings here. We're not going to mess with those too much right now. And this other one called project. All right, this is the actual project files of this project. All right, so this is a real place on your computer. There we go, rolling ball, and then assets. The other stuff is used by Unity. We don't need to get into that, just assets. And you can see scenes, and we have scenes right here. And inside of scenes is a sample scene. And if we go in here, sample scene. So any changes you make to the file directory in here will reflect inside of Unity live. It's okay. So like for example, if I went here and went created a scripts, we're going to need that eventually, folder. And we click back to Unity, there we go, scripts file. You can also do it in here, assets, create folder. You can do it within this area as well. Same context. You can see there's tons of things to create, and all these things are actual files. They will show up as files in this area as well. Whereas the stuff in your scene will not, because that's saved inside the scene as like a runtime type of setup. It's like a level in your game. Alright. So that kind of covers that. You can search, and there's a lot of features in these little windows that I'm not going to cover because, well, there's tutorials for online, and we're just looking at the very basics to get set up here. So we're going to reselect the plane, and we're going to look at the right side over here. You can see our name is up here. This little toggle turns the whole object on and off, right? It'll kind of makes it invisible, turns it off, and makes it inactive, right? So the first component, these are all components. Excuse me, you can see we have an add component. So these are considered components, and they're kind of special. So the first one that every object is going to have is a transform. And transform consists of, well, position, rotation, and scale. And so instead of dragging it like we were before, where these handles, and you're just like, okay, well, I'm trying to get it perfect, but I can't. You know, like how do I make it perfect? You can see here we got pretty close, negative 4.94. We can go ahead and just set it to negative 5, and now it is perfectly on the lines, right? So if you need like perfect alignment, stuff like that, that's one way to do it. Another way is as you're actually dragging, go ahead and press down Control, and you'll see it starts snapping to a grid. And there is settings for how the grid works, but just by default, this is how it works. And it's a great way to be able to just move things in position, like really precisely on like a blocky kind of movement, which is nifty when you're trying to align things or you know, quickly create in a little scene. The next thing is rotation. We played with that, and here you can see it changing on the right. Rotation is changing, so you can specify, okay, let's reset it back to 0, but let's say you wanted to tilt it up. You just specify 90 degrees, and there you go, you have a wall, right? I'll go put that back. We're going to use this as a floor later. And scale, we kind of covered that with the rectangular prism, the distorted cube. Does the same effect here, right? If your mesh ever disappears, if you're ever like, I don't know where it is, okay, I can move it, but I can't see it, go ahead and just check out the scale. Make sure it's not 0. You may be just going 0, 0, 0, 0, 0, 0, 0, and you may just go 0, 0, just thinking everything needs to be 0. Well, the scale is not an offset like the rotation and position. The scale is actually a multiplier. And if you multiply by 0, obviously everything becomes 0. So I'll go ahead and set it to 1, and I'll return it to normal. The next two things are kind of related. They kind of go hand in hand. This mesh filter and mesh renderer. The mesh filter is really just a component that tells the mesh renderer what mesh to render. And you're like, what the crap is a mesh? Well, the mesh is a series of vertices. We saw it in wireframe mode. It's a series of vertices as a file that composes of a 3D object in space. Every single one of these points is a vertex, an XYZ point, and together it can render objects. And that's what a mesh is. It contains other data too, which is really nifty. Like there's like mesh colors, so like you can specify this vertex is this color. It can get really complicated, really cool, which we won't be going into. But there's plenty of tutorials out there for that if you ever like start looking into that. So the next thing is the mesh renderer, and this is the one that actually controls the rendering aspect of it. Now, all this stuff looks like gibberish, and that's okay. We don't need to worry about any of this. The only thing that we are going to touch here is the materials. Now, for programming, you may have heard of arrays, and it's just like a list of objects or a list of values, like integers or floats. This is what this is. It's a list of materials, and I'm probably still speaking gibberish. You're like, well, what's a material? Well, let's create one. That's the best way to look at it. Create a folder, and we're going to call materials, and you can just enter it, okay, create, and you'll see a material right there. Click it. And we're going to name this ground. And we're just going to kind of do a test here, kind of get a feel for what materials are and what they do. You'll see that the right hand side of here, the inspector, has kind of changed, right? There's quite a bit going on here. And again, we're not going to worry about all this. This is more of an artistic thing. This is more how you make things, how a character has like really shiny boots and stuff like that. We don't need to worry about that. All we're going to do is drag this file object straight into this slot, right? Kind of see how it kind of accepts it with the plus icon, and there you see everything, this change and this change down here, and you'll see this is no longer grayed out like it was. So don't worry about all this like settings up here stuff. Like it gets complicated. There's a lot of options. What we're going to build is albedo, right? Click that little white square, and it's actually a color chooser. We're going to just choose a different color. Like you can see it changing in real time. I'm going to choose a nice gentle blue. Nothing crazy. Alright, something along those lines right there. I like blue. And that's just to make sure everything's not white, because as we spawn objects in, it'll be really white. And you can see how we have a white spot here. And really what that is the sun. It's reflecting. And we can change how smooth that is, see? You can really change how smooth that is. So if you don't like the glare, just turn this down, and it'll just be a nice solid color. Metallic, you don't really need to worry about it. Literally does what it says and make things a little more metallic-y and look metal-y. So anyways, that's the most we really need to worry about with materials. So if you ever want to change your colors of an object in your scene, create a material, assign it. You can drag it straight from here to the object itself. See how there's another plus icon? And that'll set it. And you can change the color very easily with that first option. That's the most you should have to do. The last component on this plane is a mesh collider. And so the fun thing, I think it's fun, is Unity uses NVIDIA's physics processing engine. And what that means is there's a rendering pipeline, right? There's a way that Unity renders, and it uses DirectX and OpenGL, depending on what mode you have it in. And there's also a background physics engine, and you need to add certain components to interact with this engine. And when you create the primitive objects from right here over on the left, 3D objects, right? A lot of these will come with a collider on them already because they're built in. And a good thing to know is a mesh collider takes in any mesh, right? So it could be one you created in Maya or Blender. You can see there's a list here. This is all like the default ones. But the thing to know is mesh collider is actually the most expensive form of collision detection for the engine, right? It's the most expensive because you can put in any number of vertices. It doesn't have any algorithms for fast detection. So be wary in the future of that. For a plane, it is perfectly acceptable, no problem. Just for your information, the sphere collider, which you can add here, just add component and search sphere. You'll see it's right there. That is the fastest collider, right? It's the fastest for the engine to process. Because think about it, all you have to check is a distance. How close is it to the center of the sphere? It's pretty easy. Okay, and down here is the material editor. So you can edit materials after click on the object. You'll see the same thing if you click on the object or click on the material in your project view panel over here. You'll see the same exact thing. So this just makes it easier to change the material settings without having to click and go find the material. Alright, so this last thing here that we're going to talk about is the add component. And this allows you to browse through all of the built-in components of Unity. And there's a lot. Just know that there is a lot. Like, look at that cloth. I don't know how to use a cloth. I'm sure it's fairly, like, simple-ish. Yeah, there's like wind zones, terrains. There's a lot. So, we're going to look into exactly how to add stuff that we've created instead of just adding stuff that Unity has built in. But this is where we add those scripts, right? So let's go to create a script and see if we can add one. Now, I'm not going to add it to this plane here. What I'm going to do is create another object, and it's going to be a cube. I'm going to gear icon and reset it to the center of the world. Alright, and I'm going to move it up just by dragging its y-axis there, a little bit off the cube. And you can see it's shadowed now, so it gives us a little bit of orientation, a little bit of easier like seeing what's going on. Especially when you start rotating stuff, which is what we're going to do. So the way scripting works in Unity is kind of, well, it makes sense to me. You know, but I've been doing this a little bit. No, let's not do that one. Let's see if we can do this one. No, that's not what I want either. Just a second here, see if I can find it. Alright, I guess I'm going to have to go with this one. This one's okay, I'll make it work. So this is a list. Alright, oh there we are. I wonder why I wasn't showing up before. So there's this image here, and this is the process of every frame, right, of the engine. This is the process it goes through. And you'll see a bunch of like methods here actually that we're going to use in C#. And these are the events that get called as the engine is running. So the very first thing that gets called is awake, right? So there is definitely like a way in order in which these methods gets called. So we're going to take advantage of this. We're going to kind of hijack one of these and just do some stuff. So switch back to Unity. We're going to go to our scripts page here, and we're just going to create a C# script. right? I'm going to name it rotator. Oh, turn off my caps lock. Rotator. Okay, and press enter. And you don't need to worry about the file extension or anything like that. You can see down here that I actually already added the C# file. And so just go and double click on it. It's going to open up Visual Studio. Alright, and this is the default template for a Unity script. Now I want to talk about a couple things real quick. This is a C# file. This is how C# kind of looks. This just means it's inheriting from this. And what that means is any methods, any values, any properties of model behavior as a class, anything that it has, we are going to have by inheriting from it, right? And a good example of that is, well, the model behavior has a transform component. Look at that. See, that came right up for me. All right, it's got a game object. It's got some other stuff. And it's got some methods like get component, right? That's a method. So there's some stuff we can do. Now, you may be looking at these two methods that are already here, and they may look kind of familiar. Maybe not. But let me show you. Let me make them familiar with you. Here's start. All right, so we know it's done on initialization. Start is only ever called once for a given script, right? And then update is right here, which is in the game logic section. And it's kind of surrounded by some other scary looking stuff, but don't worry too much about that. The main gist is this. It is called once per visual frame, and the reason why I emphasize visual there is there's not just a frame for visual, there's also a frame on a different time step for the physics, right? There's another frame for that. Unity is a multi-threaded engine, and its physics runs asynchronously compared to the rendering pipeline. And we don't need to worry about too much about that, what that means right now. Just know that they are separate, and that update does not actually interact with the physics portion a whole lot, or at least it's not meant to. Okay? So, to keep this super simple, we're going to get rid of start. We're not going to need that. So any methods you choose to use, Unity will adapt to you, right? So if I add start back in, it's okay. You see how it kind of auto-filled there when I press tab. That's okay. Unity will detect which ones I'm using, and it'll optimize my script for it. If I'm not listening to the start message, like for that method to be called, it won't actually even care about my script during that portion of the processing, right? So when you're creating a script and it says model behavior up there, when you're inheriting from model behavior, what does that mean? What it means is your script is not just, a script in the background for the program. It's actually a component. If I click on cube here and go to add component, and I just start typing rotator, look at that. It's right there. That's my script right there. See? Added right there. You can also drag and drop. Drag it over here, and you'll see like a line show up over it. You can choose where you have it. You can't put it above transform. You can put it there, 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 and at the bottom. Right, I already have it, so I'm not going to add it twice. And there it is. Now you can also double click on this, and it'll open up the script again. Okay. So in C#, there's these classes, and we have classes here, and it's inheriting from model behavior. And what that means is this is a blueprint for every rotator object that's added to an object in the scene. This is going to be initialized as an instance class. You cannot have a static form of a class inherits from model behavior, because model behavior is meant to be a multi-object capable class inside of the scene. And to better visualize that, we have the cube here with the rotator script. I can duplicate that cube, and now there's two slots. You'll see I'll pull this off, looks more apparent. There is two rotator scripts existing in my scene, two different ones. They have different variables when I add them. They'll have different values, so it's kind of like in programming when we say new and then the class name, and then invoke the constructor for it. That's what this is. They're two different objects, and it's a more visual way and a more actual, almost like a physical way to create them and manage them. And so it's a little bit better idea to get a sense for what instance objects are, how they behave, and etc. And the next thing I want to talk about instance objects is scope. And what scope is, if you've never heard of it before, is how accessible a variable is at any point in a program. And The best way to really get a grasp of this is to go ahead and experiment with it, right? So you've probably heard of public, right? We have it in our class there, and we're going to make a public just primitive int, right? And I'm just going to call it rotate amount. And I'm going to shorten it to a camel case, so lowercase first letter and capital case to everything else, every other word rather. And I'm just going to set it to 1, a default int value. And we're going to see that because it's public, meaning accessible outside of this class, Unity will actually access it. We'll see that here. We'll see it show up right over here. See that? Rotate amount and a value. And we can change it. We can say 5. And with the whole instancing I was talking about, if we have a separate cube, you'll see it still says 5, but I can change that to 2 now. I can change it to 200. It doesn't matter. My original script still has the same reference to the object, which means they are separate. They are working no longer with the same values. Go ahead and delete that. We won't need it too much. Right. So that's how you get a variable to show up. If you make a none public, you can say private if you want. Right? Or you can just leave it off. It's pretty much the same thing as C# here. And save and switch back. You'll see that it compiles, but it doesn't show up. Nothing's there. Because it's not accessible, right? It's not accessible at all. You will see that we got a warning here that says the other int is not used. Well, that's because we never used it. That's okay. We're not going to. So, that's how kind of variables are kind of working here. We're not going to use an int. We're going to use a float. And a lot of things in Unity use floats, and that's because of precision. Unity doesn't want to be super precise and use the double byte allocation of, I believe it's doubles, and because it's too much memory, right? They want to be optimized, but still have a little bit of precision. We can't use ints because we want some decimal precision, so we use floats. So I'm going to specify the same exact name, but now I'm going to say, I don't know, 2.5. And in C#, you have to say F, right? You have to designate, okay, what I'm saying is a float. If you do this, Unity is going to tell you literal of type double cannot be implicitly converted to type float. And the reason for that is the C# language think that's a double, which is double the precision of a float, right? So we can't implicitly convert from a double to a float without precision loss, meaning we lose bytes of precision in memory. So it doesn't want us to just kind of be careless with our creation. It wants to specify, yes, we do want to float. We do not care to lose that precision, which we don't. Okay, so that'll show up. And one thing I want to note is I said equals 2.5. This is not the value it's going to equal in Unity. You'll see that when I switch back here, it still says 5. You'd be like, well, that doesn't make any sense. I said 2.5. What this is actually a default value. As you know, in some instance classes, you can specify a default value, and then your constructor may change it. And that's kind of what's happening here. Unity is changing to the value we had specified. We had customized it already. And it doesn't want to reset your variable back to like the default value in case you had it already set up for, like a precise thing. Like what if your character was supposed to, like a trigger was supposed to happen to trigger like cutscenes or an animation or like an explosion when he reached 20 meters down a hallway. Well, if you already set it to 20, but the default just happened to be 10 for that script, and every time you compiled, it reset to 10, well, that'd be super annoying. It wouldn't make a whole lot of sense either. So that's something to keep in mind. Now, you can set it to the default, by the way, by going to the gear icon and reset. And now you see 2.5. Alright, so that's one way. You can reset your own scripts too. Alright, so for object-oriented programming, we have a bunch of objects, and the Unity API has tons, absolute tons of objects. So we're going to keep this as simple as we can. And what we're going to do is we're going to call all of these objects currently in the scene here, right? All 4 of them. These are actually called game objects, and because they're part of the game and they're currently an object. So let's type game object, right? And what this means, what we're referencing here is the current object. So we're not referencing the script because we'd use this for that, the keyword this references this script. And you can see we can access a rotate amount that way. You can also do it without this because it's in the scope for it. But no, game object is referencing the entire thing over here, like this from the cube and all these components. They're all underneath this game object called cube, right? So if you want to affect this object, you can use that. Now, because this script is attached to a game object, you actually don't need to reference game object a whole lot in your script. So what we're going to do is we're just going to rotate this cube, and it's going to be really basic, but we're just going to rotate it. And as we talked about, when you rotate things in the scene, it changes our rotation component of our transform, and we can access that transform from a script. Just like that. Transform. And this is referencing that same transform component on this object the script is attached to. So if you have two different objects with this script on it, the transform it's referencing will be different. It'll be actually two different things. One will be its transform, and the other one will be the other transform. Sorry about the mic issues there. And so we want our current transform, and what we're going to do is just call a method called rotate. That's super basic, right? Now this is where things get kind of weird. So there's another class, another object in Unity that's called vector3. And if you're not really familiar with vectors, all this comprises of is an x, a y, and a z, which all happen to be floats. So you can see it's expecting a vector3, and this is Euler's. We don't worry about exactly what that is right now. What we're going to do is specify vector3, and we're going to reference the static object up, right? And what this is, it's going to return a new vector3 object composing of x equaling to 0, y equaling to 1, and z equaling to 0. And you can see that if you pause with the up selected, it says shorthand for writing vector3 0, 1, 0. So even though it's a static object, it is actually returning a new object. So we don't need to worry about like changing something in the vector3 class. No, they have it well protected. It's fine. This is just returning a new. You can actually see it's a property, not even just a static variable. It's actually a property. So what they're returning is just a new vector object for us to play with. So this is actually defining the axis of rotation, because if you specify 360 degrees on the y component of a vector3, you rotated your object all the way around one full turn. So we are working in degrees here. So vector up is actually going to be 1 degree. Well, that's nice, but what if we could control how many degrees we turn by multiplying 0, 1, 0, multiply that by our rotate amount. Well, let's say our rotate amount is 2.5, then this vector will come out to be, pretty basic math here, 2.5 and 0. So it's going to rotate 2.5 degrees. So by having a variable here, the rotate amount, we can control via the editor visually how fast our object rotates around the y-axis upwards. Right? So that's kind of cool. So this will actually work right now. We can just switch back over, compile, let it compile. You see the little arrows show up down there, and go and click the play button. Right? And you see our camera, and there it is. It's rotating. Look at that. Pretty cool. And you can increase the rotate amount. Just go and you see arrows show up when you hover over this. Click and drag, and you'll see it increasing. And you can even go all the way down and even negative. Right? And spin the other way. You can control it live. And this is a great way to kind of get a feel for how variables work, how Unity works, how instance stuff works, and you really get to play around and kind of create something kind of fun and learn scripting at the same time. And you'll see that we won't be working Unity a whole lot actually. We'll be doing a lot of stuff via scripting, which is really cool. Now something I want to note is this was 2.5 before I started. I changed it to 5. If I click the play button, which will stop and exit play mode, you can also pause, by the way. You'll see that it's just paused. It's still playing, it's just paused. And then you can do frame by frame this way. But if you just exit play mode, you'll see that this value is now 2.5. It's no longer 5. And the reason why is when you're in play mode and you change something in the editor, it actually reverts back after exiting. And it's not everything. It'll persist all the files you create. So if you create any material stuff, that'll still be there. But if you change any variables, if you change any objects in the scene, their changes won't persist. And there is a way to actually make it persist though. So if you click play, and it'll start rotating, right? We're going to go scene view and look at it. It's pretty cool. You can actually you don't have to pause it. You can just click scene view, and then you can play around and watch it live action really close, in case your camera's on a good angle like ours isn't. And you see 2.5, well, I'm going to double this to 5, and via this gear icon, you can copy the component, just like that, exit play mode, you see it reverted, that's okay, and then paste component values, there we go, that one. This will paste a whole new object, we don't need that. We just want the values, and bam, we're at 5, right? But there's a problem here with our object rotating, right? So I'm going to go ahead and get this view. You can see it's rotating at good speed. Now I want you to think about something. This is updated per frame. And the issue here is I want you to go ahead and look at my frame rate. It's at 70 frames. Okay? That's fine. And it looks to be rotating just fine. So what's the problem here? The problem is, if we go to, no, not graphics, I always get those two confused, quality. This is where you can kind of control some more advanced graphical stuff. We don't really want to worry about anything. I'm just doing this to show a concept. You may have heard of what VSync is. VSync, alright, so VSync is where the game engine, the rendering pipeline, your graphics card basically, tries to sync up with whatever monitor it's displaying on to be the same frame rate. It does its best. It's not perfect. Even with VSync on, you see it says every V blank, right? Every frame will look how much this is bouncing around. It's not perfect. So the issue that can come about with this is when I turn this off. Watch what happens to the cube, right? So it's spinning there. Now look at it. Look how fast that is. I'm hitting 2,000 frames a second. And the issue is I'm actually, every frame, I'm moving 5 degrees, which means per second, I'm moving 2,000 times 5 degrees a second. So right now, this cube is actually variable, not just based off this rotate amount, but also my frame rate. If my frame rate goes higher, it'll spin faster. And you may not want this. This could be an issue, right? So if you have a car and its wheels are turning and you use some type of update method to turn it, if the frame rate increases, the tires will actually spin faster than they're supposed to. They won't be realistic. So, and there is a way to fix this, and it's very simple. Back in our script, go ahead, we're going to multiply this by one more value. And we're going to reference the time class. And a specific value, oops, I had the words backwards in my head there. A specific value in the time class. And this value represents how much time has passed in the last frame. So, in seconds, by the way. So if you want something to rotate 60 degrees per second, and you only moved 0.05 seconds, you should only move 0.05 times 60 degrees in that frame, right? Kind of makes sense. So that's what we're doing. This is how much we want to rotate by per second. And per second is defined right here because this is how much of a fraction of a second we've actually processed. We've not processed a full second. We've only processed a portion of a second. So only rotate a portion of the full second amount that we're trying to rotate by. This is the degrees per second of rotation. And remember, this vector up over here, the rotate method requires a vector 3 of 3 axes to rotate on. We just want to rotate on the up axis, just rotate around and around like this. And that axis is the up axis, right? That's Y1, right? And so this is an easy way to reference that. So now that we've done that, let's go ahead and head back here. Let it compile. I'm going to go ahead and reset this to 0, and we're going to play again. And we're not going to see much changing. Or are we? Look at that. Look how slow that is. It seems just horribly slow, almost like it's wrong. But think about it. That's 5 degrees a second. 1, 1,000, 2, 1,000, 3, 1,000, right? So that was 15 degrees. Let me go and change this to 360, and you'll see that, look, follow a corner and count 1 second. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1. See? It's 1 full revolution, 360 degrees per second. And this does not matter off my frame rate. Let me go ahead and unlock my frame rate again. Quality, don't sync. Look, 1,000, 2, 1,000, 3, 1,000. It's the same thing. And you can see that we are now rendering very high again, up near 2,000. Okay? So that's something to keep in mind when you're moving objects per frame like we are, because updates called every frame. Go ahead and try to make sure that it's actually, moving appropriately per frame rate, because if you have things that depend off a frame rate, you're really limiting, the kind of people that can run your program. I mean, if I have a really bad computer, your object's going to move horribly slow for me. If I have a really nice computer, they're going to move insanely fast and even make the game unplayable. So those are things to think about. Alright, so we have a nice rotator script here. We're actually going to do a couple things to make this a little bit nicer. And there's a reason why, it'll become a little more clear later. But what we're going to do is make a similar thing to what a pickup would be, like in a game, like an item pickup, right? So what I'm going to do is I'm going to rotate it 45 degrees that way, and I'm going to rotate it 45 degrees on the x-axis, the z-axis, right? Let's get a kind of up and down from corner to corner kind of view going on. And I'll bring it up a little bit. And this is a little big for what we need, so I'm going to do 0.5 on all my scale here to make it half the size. Bring it back down near the floor here. And I want this to kind of look like a pickup. I want it to kind of look like bright, vibrant, like something special. So what I'm going to do is go to materials and create new material. Just like this. And I'm going to call it pickup. And while we're at it, let's go ahead and rename this cube to pickup. Right? Oh, whoopsies. Right? This is going to be a pickup. And so, great. Now we've made a material for it. Let's go ahead and assign it. I'm going to drag it over here, right there. You can also drag it onto the object itself. It's kind of easier. And I'm just going to add the material from in here. And I don't know, I'm feeling a little bit of a nice green color. Kind of contrast from the blue. Right? There we go. And there's like a little object we're going to pick up. And it's going to give us some points or something. Alright, really basic, I know, but just try to imagine with me here. Right? Okay, let's go and play and see how things are going. Right? Oh, we're moving quite slow again. Let's go ahead and bump this up to, I don't know, 50? Is that too much? Oh, no, let's do 90. 90 is not bad. I like 90. Okay, so this is great. It looks kind of weird, though. Right? I mean, it's rotating, but I thought we had said it would rotate along this axis straight up and down, and it looks like it's rotating on like an angled axis. And this introduces a new concept here, and this is the fact of local versus global. And you can toggle the two up here with this local versus global toggle. You see a change here? Global is literally like this up here. You see this? See those axes? It locks it. It's the same thing, see? And even though we're rotating, you can move along those axes, which makes sense, right? But the thing to think about is the object's axis has his own local, like, axes of movement. The object has its own up direction. And that's exactly what we did. We told it up. Now, this was 0, 1, 0, but the rotate method, the thing to know is you're rotating according to the transform. And rotating to the transform actually means in relation to the transform. And we rotated our object to be on its kind of angled side like this. So it's rotating on this axis. Luckily, there is an easy way to fix this. We just have to introduce something else called space. And you have two options, very simple, self and world. Self applies transformation relative to the local coordinate system, which is what it's doing right now. That's the default. What we want is the world. We want to use the world's coordinates. Alright, so let's go and save that, come back here, and just see if that works. Okay, we're still slow. I keep forgetting to reset my value here. Go and do 90. Look at that. Even though our y-axis is spinning around, we're not spinning on the axis itself. We are spinning on the vertical up and down axis, which is what we want. We want our pickup to kind of spin like this, like it's like a top or something. Okay. Now, we made a rotator script. We didn't make a pickup script. We made a rotator script. So what I'm going to do is this is actually an enumerator or enum, and you can actually make these publicly accessible, just like this. Oh, helps if I spell it right, doesn't it? There we go, space. And this is a new variable, right? And it's public, which means Unity, we can change it within the editor, and I'm going to replace that with our variable, which is just going to plug in the current value of what we have space set to. So now, switch back to Unity here, kind of switch back and forth a lot. This introduces the next problem. You see here, if we click on the bottom bar here and it goes to our console, you see we have issues. We got 5 errors. Unknown. The reference script unknown on the behavior is missing. Well, we have our pickup selected and it's right there. What's the problem? And this has to do with compilation versus the runtime event in Unity. If it compiles while it's running, it's possible, depending on the script, that it no longer has the ability to run. So try to make sure that you're not in play mode. If you save something and come back and see yourself in play mode, just click it real quick. You should be able to catch it before it compiles. Nothing breaks necessarily, but go ahead and just, make sure let it compile without it running. And you see we now have an option, a drop down between world and self. And not only that, but we can test this in play mode. See? Oh, okay, I did it again. I'm just going to do this now, that way I never forget about it again. 90, and replay. Alright. See? We're rotating on the world axis just like we were before, but now you can just toggle this anytime. See? Just change it. Whatever you want. You can just kind of play with it. And this is what we're really going for here, is we're actually taking our script and making it more generalized. Yes, we want our pickups to rotate, but we also want to create some scripts that can be used globally, right? So what if I wanted a script that could move a fan in a building, like a little fan on a ceiling fan? All right, this would be a perfect script for it. It just rotates. It's very simple. What about like a helicopter blade, or of course, airplane propellers as well. And there can be a lot of uses, and you don't need to necessarily create a different script for each of those objects. You can use one script and kind of contextualize it into different ones. And the last thing we're going to do here to do this is we're going to actually make our own vector3 object. And we're going to call this the axis. And we're going to replace our previous hard-coded axis with this new axis. And we're going to see the changes here. You see myself playing. I'm going to click it real quick. And it catched it. I didn't catch it fast enough. That's okay. It doesn't really hurt anything. Just be careful about that. You see your axis is now 0, 0, 0. Okay, so let's go and play and make sure it works. We're not rotating. Okay, so what's going on? So rotate's about 90. We're in world space, so that shouldn't really matter. Our axis is 0, 0, 0. It shouldn't matter, right? Oh, of course it does. And change it to 1 on the y. And this is because, right, so we had vector3.up going previously, which was 0, 1, 0. And we no longer do, right? We created a new vector3, but the vector3 doesn't know it's supposed to be up initially. We can set it so it's the default to up. That's no problem. In fact, let's create, defaults for each of these space, and we'll do, probably self space will be more common than world space, and our axis is going to be equal to vector3.up. Now you could have done new vector3 and then 0f, 1f, 0f, like that. This is just vector3.up is a shorthand for that very same thing. So it's just a little bit easier. Okay, and we'll catch it this time. See, I caught it that time before it compiled, and I'll have no issues. And see, now it still says 0. That's because I had defaulted it to that. Now I reset it. You see 1's there. Our 2.5 is back. We don't want that. We want 90. And we do want world instead of self, and we want it on the y-axis. And now you can take this script and throw it on another object and kind of contextualize it. And to give you a good example, I'm going to create one real quick. Right? So we're going to, there it is. Kind of got pushed out of there. Reset it. Bring it up. And I'm just going to scale it down to look a little more like a propeller. It's going to be kind of an odd looking propeller. Just like this. And make it flat. Okay, that's a huge propeller, but that's okay, right? And it's got the box collider. It's got a mesh renderer to make it actually visible and everything. I'm going to add the rotator component that we created. There it is. 2.5, you see it's starting to rotate. Well, that's not really what we want. Let's set that to 0. And that's effectively going to stop the rotation, allowing me to reset it. And I do want it in its self space because I'm going to rotate around the x-axis, its own x-axis here, like a propeller. So x should be set to 1 then to turn on the 1 axis. And we can now turn this back up. Uh-oh, we got some issues. And so this kind of brings about another problem that you may face. And this problem is sometimes the rotation using Euler angles, which is what this is, really under the hood here in the engine, it's actually using something called a quaternion, which is a 4 float valued object, x, y, z, and w. And angles can get a little complicated. And when you're using Euler angles, which is the x, y, z version of them, you can kind of get this effect, which is incorrect, obviously. And it just has to do with miscalculations in terms of how to calculate the rotation. And this is just kind of just a bug, really, inside of the vector calculations. But there is an okay way to fix this, right? So I'm going to turn this off. You set the rotate amount to 0 or the axis to 0, and it'll stop rotating. Oh, I'm silly, aren't I? That's my fault. There we go. So this should work, actually. Whew, fast. That's because we don't want 90, we want 1. There we go. So the problem I showed you was actually just me being silly and not remembering that the Y was turned on. But it does happen. When you get more complex objects that are like parented and nested and stuff, you can have that issue with vector manipulation. So just be careful of that. Obviously with this, it looks like it's working fine. Thankfully, I didn't want to have to try to fix that. Keep it as simple as possible here. You can see we're rotating, and it's a very slow propeller. So we're just going to click and drag just to get us up to a more propeller speed here. We're getting there. Right. And so something that's interesting is you'll see, like, when we look at propellers, they don't they don't, what am I trying to find the words here? They don't look like they do right now, where you see, like, it looks like there's multiple propellers. We see like a blur, right? And that's just how our eyes kind of process images and process colors. The rendering pipeline is taking images, right? It's taking a picture, it's drawing a picture every frame. And in that frame, that little propeller is at a certain position. So that's why we're not seeing a blur, because it's actually drawing a bunch of images really fast. And the reason why we see multiple at one time, that's our eyes actually can't affect because we're seeing multiple frames really fast. So that's why we're not seeing a blur effect. In any games that show a blur effect, they're actually use special techniques to show that blur effect. So yeah, we used a rotator script to kind of repurpose it. We can make it for a fan blade and stuff like that. And that's kind of the point here, is you kind of want to, oh, that's fine. You kind of want to sometimes repurpose things or make things more general so you can make it applicable to anything. Look, we can define any axis in any space, any rotate amount. That's going to be super useful. Maybe not in this project, but eventually in other projects. Right. So there's one other thing I want to talk about, and it's this value right here, is trigger in the box collider. And you can turn on or off. What this means is, trigger means if it's on, any objects moving in the physics engine will just pass right through this one. It's like if you ever played a game, it's something you're walking down a hallway and something changes as you go down the hallway. Some screams occur if you're in a horror game. I don't know, part of the building collapses if you're in like an FPS, like Battlefield or something like that. It's really a trigger collider. They don't actually collide with anything, right? So if you throw like a physics ball at it, the ball won't bounce off of it or anything. It'll actually go right through it. And the reason why these exist is for you to be able to find areas in the game to detect anything going into that area. And for a pickup, you actually want to detect if the player goes into it. We don't want the player to collide with it. Some games do that. We're not going to. We just want to detect, did they enter our area? Did they pick us up? So we're going to enable that, right? And this is kind of our pickup object. So I want to introduce something else. And I'm going to create a folder for this, and it's something called prefabs. And this prefab is a folder that stands for prefabricated items, and short to prefabs. And we're going to take this object, and just bear with me, just pick it up, drag it, and drop it into prefabs. And you'd be like, wow, it just created a file. This is an actual file. Show and explore, look, there it is, .prefab. The meta file is just for Unity's managing files, so don't worry about that. This is the actual file. And so, if you actually open this up, here you go, look at this. Whole bunch of stuff. But you can kind of see what's happening here. Here's the game object. Here's the components listing as IDs. Okay, it's kind of weird. Here's the name, though. We did specify it was pickup. Right? Here's the transform component. Here's the mesh renderer. Right? And then here's a mono behavior. Well, what's that? We know what that is. We created that. It doesn't have a name, but we don't have to necessarily worry about that. Here's our variables. Look at that. Rotate amount, space, axis. So a prefab saves the current state of an object. But they do more than that. You see how it's blue now? You'll see some new options up on the top right here. You see select, revert, and apply. And you're like, wow, what does that mean? So go ahead and click on this prefab and look at the transform. You'll see that it's positioned upwards a little bit. You'll see it has a rotation amount. And the scales here. Everything's still here, just as it was in the scene. Well, just take it, drag it, and look. You can actually, and we're going to change to global so I can raise these up a little bit. Just drag these out now. You can just duplicate all that work we did creating it on the fly. Instead of having to go, okay, right click, duplicate, move it. And that's a great way, but now that's a file. This file persists across levels. You can reference this file in a script to spawn these objects, right? This is really useful. What if you had, like, I don't know, a chest, right? And this chest has loot in it, and you want to place those chests in like a dungeon. Well, you can just create a prefab and then just start dragging it out. And then like you can have a script on each of them that just kind of loads what loot they're going to have randomly, right? On the fly. Unity has some built-in random classes for you to use. So now, look at this. And they all have the rotator component. Something else that's really cool, prefabs retain their file's parameters. So if I increase this, you'll see nothing happened. However, if I increase it, you'll see that this persisted out of play. And that's because it's a file. Any files you change, create, delete, whatever, play mode doesn't affect because they're files. That's all you're changing your files. You're not affecting play mode. But now look at these ones. They all have that value now. They dynamically pull this object's, this file's parameters. Change this to self. Click on one of the actual objects in there. Look, self. So prefabs are a great way to control a lot of things at one time. I mean, otherwise you'd have to go like, okay, click this, click that one, click that one. Okay, now we can change everything. Okay, now it changes itself. And that's just kind of crappy, especially if you have a really like optimized level with tons and tons of objects. I mean, like, think like Skyrim. How many objects do you think would be in this list? Absolute tons, right? So prefabs are a great way to go ahead and just make things a little bit easier, right? Because it did not take me very long to create, 8 objects? 8 pickups? It was easy. Also, I want to throw in here, you can actually reorganize this, kind of drag things around and reposition it. I'm going to rename this to ground, just so I know. Okay, so we have some prefab objects, right? We have some pickups in our scene. Well, we don't even have a player. What are we doing here, right? This game doesn't make sense. You click play and it just, these green cubes rotate and we're just sitting here. And yeah, they do like a little dance, looks like, but that's it. Okay, doesn't look too great yet. We don't really have a game yet. So let's go ahead and make a game. Let's go ahead and add what we're going to need to make this playable. And it's going to get a little weird, so bear with me. But I will not lead you astray in this part. Just kind of follow along and try to kind of think about what I'm doing. So I'm going to create a 3D object here, a sphere. this is a rolling game, and well, spheres roll, right? So we want a sphere. I'm going to reset its position, right in the middle, raise it off the ground a little bit, right? And so there's our object, right? That's our player. I'm just gonna make it pretty. Create material for it just for fun. This is gonna be our player. You can call it whatever you feel like. Assign it, and then we will, I don't know, how about nice red maybe? Nice maroon. There you go. And I would like to make this look a little more metallic-y, like a marble. So I'm gonna increase this value. Look at that, almost like a Christmas ornament. There we go. You see we got some nice reflections going on now. Kind of nice, right? Just something to play around with. Okay, so we have a nice marbly looking thing. So let's play. Let's play our game. We have everything, right? No, we don't. See? We can't. Nothing happens. We can't. We're stuck. Okay, so let's make this actually do something. And so it has a collider, which means it's in the physics engine as something that things can, well, hit. But the collider itself doesn't tell the physics engine that, hey, this object needs to be able to move, right? This object needs to have velocity, rotate, unlike dynamically. Like, have you ever played a game where you push the door and the door swings open based off your character, right? That's physics. That's just velocity, angular velocity. Well, where is that? There's actually a component for that, of course, and this component is called a rigid body. Go ahead and add it, and you're going to see some physics-y settings here. And what this component does, it works together with the collider, and you can have either one without the other. This just is like a complete physics setup. This now will have gravity. It'll collide because it has a collider. It'll have a velocity, has angular drag, has normal drag, has mass, and there's even some more advanced stuff here. And the constraints here is kind of important to mention because I did mention a door. Well, a door only rotates on the up axis, so you can actually constrain the rotation on the x and y and only let the y be free to freely rotate, right? So that's something you can just keep in mind if you're ever creating like a door. That's a thing. So we're not going to change anything in the rigid body. We just need it here to make things work. And to show that it works, what I'm going to do, and you don't have to do this because I'm going to delete it afterwards, I'm going to spawn a plane. I'm going to rotate this plane just like this, nice and steep. I'm going to pick up our ball, a sphere, move it to the top, and we're just going to watch what happens. Right? I'm going to click play, switch to scene view, and look, it's rolling, it's colliding, it is going, and it's gone. And it shall forever fall. And it really will. No, I'm just kidding. It won't forever fall. It'll fall until these values, the position values, become too large for the memory to handle. And, well, it'll error out. And, yeah, you'll have to quit. So, but that's like a long ways down. It would take a while. So, yes, we are now physics-based. This sphere can now collide. It can roll. It does what it needs to do. But we can't control it yet. And there's a reason for this, and that's just because, yes, we put it into the physics engine as a physics object. That just means it reacts. That just means it'll roll. You know, it can be hit, it can be thrown. But we don't actually have anything to say, hey, you're being thrown now. We don't have anything saying that. So we're going to create a little script for it that's actually going to let us control it rolling around. And before I do that, I'm going to grab the camera here. I'm going to move it a little closer and a little higher, move it up, and I'm going to rotate it down to look at the scene. And the reason for this is our previous angle was not great. And now, we can actually see our scene a little bit better, right? Okay. So here's what we're going to do. Our sphere here, it's got the rigid body, collider, and some mesh rendering and filters, and its normal transform. Go ahead and click on this to minimize the material properties. What we're going to do, there's another way to create a script. And there's like two ways within this one way. So what we're going to do, I'm going to call this player manager. And as a type, you're like, oh, well, nothing showed up except new script. And you can click new script, and you're like, okay, and then it says player manager and create and add. This will actually create a C# file with the class name player manager. The only downside to doing this is the file will not be in the scripts folder. It'll be on the root directory of the assets folder. It'll be like on this level up here. And that's just not ideal for me. I prefer just going through the menus and creating it. You do it how you like. The other way within this one way is clicking new script, and then you're at the same place. Just now you have to type in the name. So yeah, those are the ways to do it. I prefer going through here and just right-clicking, create C# script, right? Everyone has their own preferences. Okay, let's go and open this up, right? And here's the default layout again. We do want it to be model behavior because it is going to be initialized onto an actual scene object. And what do we want, right? Well, how do we really work with the physics system to get this working? And I'm just going to clear out both these methods. We'll use them, just not right now. So we just got to think about what we want our sphere to do. Remember, this is going to be attached to the sphere. What do we want? Well, we want it to roll around, and we want that to respond to input, right? We want it to move when we press the W, A, S, or D keys. How do you do that in Unity? Well, here you go. The first thing we're going to want is a public, because we want it accessible in the editor, float for precision, and I'm going to have a move force. And I'm going to set this to 5. Right, and you may be like, I don't know what that means or what that's for. Don't worry. Follow along. You'll see in just a second. Now, we could do void update. But as you remember, this is called every frame, every visual frame, every rendering frame. And as I told you, we're actually going to be touching the physics engine. And you shouldn't really touch the physics engine during update because it's not on the physics interval of time step. The rendering pipeline can run over 2,000 frames a second, but the physics engine will stay at about 50 frames a second. And that's because it wants constant calculations for all of its physics objects. It's really an optimized thing. And so you shouldn't be adding force or messing with, like the velocities and stuff in update because you can get some weird results since it is every frame and not every physics frame, but every rendering frame, which happens way more often, especially with nicer computers. So we don't want that. But you see there's another option up here, fixed update. And that just means every fixed amount of time this gets called. And that's why the physics engine uses this. This is why if you go into this is where you should be doing your playing in the physics engine because this is actually ran along with the physics engine. This is where it's meant to be. And you don't have to worry about like the frame stepping. You know how we did multiply on a rotator script up here by time.delta time? You don't have to worry about that in fixed update because any changes made to physics objects in this update is actually already calculated. It's already, applied the delta time, except it's for the physics engine delta time, which you can access, by the way, by time.fixed delta time. And that's just the amount of time between each frame. Fixed time will tell you how long each fixed update takes. And that the fixed update or the fixed time itself tells you what time the fixed update method started, the last frame. So we want to play with our object. And to play with our object, our rigid body is the one that actually gave us the velocity and the movement. So that's the one we're actually going to touch. Now we can't just say rigid body. You'll see this come up even if you start typing and you'll be like, well, why can't I? Well, just look. It's deprecated. We used to be able to go ahead and just specify, oh, I want my collider. Oh, I want my audio. That's all deprecated now. Sorry about the spitting into the mic. That's all deprecated. So you actually have to go through another means. The only two that are valid now are game object, which references the entire object, and then transform, as we used in a rotator script. And transform is just a quick way to get to the transform component. And the reason why the others are deprecated is because there's too many issues where your object wouldn't have the component you're seeking, like an audio component. You can so easily reference audio in your script as if there is one, even if there's not one attached, which led to too many errors, and so they actually just deprecated that. But every game object is going to have a transform, which is why that one still works. We're actually not going to use transform either. What we're going to use is a reference, and we're not going to use primitives for this. We're actually going to use a reference to an actual object. And we want to play with the rigid body. That's the one that actually has the force and the angles and, not the angles, but the angular velocity and the normal velocity and the mass and drag and all physics-y stuff. right? So we want the rigid body. We need to talk to it. So we're going to get a reference to it. And there's a couple different ways you can do it. You could make this public, so it's accessible within the editor, like that. And when you switch back, click on our sphere, you'll see, well, you have to add the script. Don't forget to do that. The good thing, I guess the benefit to doing new script is it'll automatically add it to the component too. You'll see that we have none for rigid body. You can fix that. If you have a reference like this that says none, you can click the little icon over here, and it'll give you a list of every object that has a rigid body. Our sphere does. You can also click and drag the sphere over to the spot, and if the object has the required component of the type of rigid body, it'll turn like this positive, or the plus sign, and you can drop it in. But I don't like doing this, and there's a reason why, and it's because it's not necessary. And the reason why it's not necessary is there's another method called awake, and this is the first method called when the game starts up. And the reason why I like this method and doing it this way is there's two methods that get called, awake and start. Start is called after awake, right? So what I like to do is any references to objects or components, especially on the same game object like a rigid body is, I will just go ahead and get the reference from the awake method. And this saves cluttering my editor. It makes things feel a little more clean. For example, I'll get the rigid body here, and then if I need to initialize, like, okay, set the rigid body velocity to 0. And don't worry too much about what I'm typing, just know that, that sets velocity to 0. It's pretty easy to see, actually. You can't reference the rigid body until until you actually get the reference, which is why I get my references here, and then actually play with stuff starting in here. It's just a clean way to do it. It's a guaranteed way to make sure your variables will not be null when you try to use them. The other issue I want you to think about is if we have several objects of the same type, same class and everything, that use the awake method or start method or update or fixed update, if you have like 50 of them, they won't execute. Like, each of them will not execute in an order. It'll be random every frame, and that's just from the optimizations done by Unity's part. There is no order that each of those methods is called. Now, all of the awake methods called on every object will finish before any of the starts are done. So that's good. That's why I have them separated. So like, for example, if I had a reference in this script and another script needed that reference as well, but it used my script to get that reference, which I know seems really convoluted and a crappy way to do it, I would actually can't guarantee that the awake method in the other script would get called before this one, or vice versa. There's no way to guarantee that. The only guaranteed way to do it is awake and then start. And then late or update and late update are kind of similar in that aspect, except they're called every frame. Like start and update are update. Start and awake are just called when the game starts, whereas update, fixed update, and late update are all this every frame. So this is my method. You do it how you like. It is approximately the same. Like time and memory, it's about the same. It's not too much different. Initialization doesn't take too long. So this is how I do it. So I set our reference of the rigid, which is what I named it. You can name it whatever you want. That's a type rigid body. And there's a method inside of the monoBehavior class that we're inheriting called getComponent. And it actually uses a generic type. And what that means is you tell it what type, and it will go get that type for you. And there is another way to do this, which I don't know if it's exactly a good idea, and it looks like the same method except use the normal function, and then you specify this as a string. And the reason why this is not liking me, see, here's another, yeah, exactly, this is exactly why. Look, I had to not only specify and type out as a string form the type of object I want, I then have to cast it to that object, whereas the generic can search both for the type I ask and return the type I ask. So this is why this is generally preferred. This is just not as clean. And it's also slower because this function actually has to search for this type, it has to parse this into a type and try to find it. And then you have to go through converting when it gets back here. So be careful about that. I suggest just doing generic type. It looks a lot cleaner and gets things done. Okay. And by the way, this get component is actually attached to game object like that. It's in there. So you can actually do it by transform as well. So keep that in mind. Any of those like high level game object-y names, you can actually go ahead and do get component from them. In fact, I believe you can even do this .get component. Yes, anything that is a mono behavior has a get component. Game objects a mono behavior, transforms a mono behavior, this is a mono behavior, so they can all do it. So that's how you get another component attached to the object. Now, if I do not have a rigid body attached, this will return an error. And this is a quick thing. This isn't something that's required. It's kind of nifty to do though, especially if you need to guarantee that there needs to be a rigid body for this script to run. You can do this by up here in brackets. It's kind of like a flag for Unity. You can type require component. It's kind of like a function. See here, and just do type of. This is kind of more higher level programming here, so don't worry about it too much. Just know that doing it this way. Oh, I spelled type of wrong, silly me. Will actually enforce before anything runs that this game object has a rigid body if this script is attached to it, which is really nifty. So if you cannot even remove the rigid body if this script is still attached, it guarantees that the rigid body is always attached. So with this flag up here, this is impossible. This is impossible to be null. Impossible. Whereas if you have this off, if you have this commented out, this can be null and give an error if you don't have a rigid body. With it though, you can make sure. So if you add this script, it'll actually add a rigid body as well. Oh, what did I make it mad about? Oh yeah, the little bracket. Oops. Okay. So that's something nifty to know. The type of is just a function built into C# to go get the type of whatever class you give it. And it returns a system.type, which is required by the require component function. So that's just a little complicated there. You don't have to worry about that too much. Just make sure rigid body is attached. So let's actually do something with the rigid body, right? We've been talking about programming and just these topics, and it's getting kind of down a rabbit hole, it seems. So let's bring it back up a bit here. We want to move around, right? We want to roll. So we're going to do something really simple. We're going to grab our physics rigid body. Let's add some force, right? This is actually like a physics calculated force. This is legit. This is not just like some guy waving his hand like, yeah, add force. This is actually, yes, we're adding force. And it takes a direction multiplied by a force. How much force, right? So it's a vector 3, and vectors represent directions in space. And like the up axis points up. So we're going to specify a direction that we want the ball to roll in. And the length of our direction, the magnitude, or what we multiply our direction by, which will be our move force, is how much. And this is pretty easy to do, honestly. So what we're going to do is, I'm going to specify vector 3.0. Alright, and that makes no sense, right? Because we're effectively adding no zero. We're adding no force, rather. And that's just useless. We're going to change it here in a second. But we need to set up a couple things first. So I'm going to create a local variable. And this is going to be a direction. And I'm going to set it default to 0. Right? And I'm going to now change it to equal vector 3 right, which is, if you look, it's 1, 0, 0 as a vector 3, x, y, z, x. It's the positive x direction. And I'm going to multiply that direction by input. Ignore that, don't type that. Get axis, horizontal, yeah, spell it right, otherwise give you errors, and colon. Right? So what happened here? We took the right direction of the world, multiplied by how much this input.get access returns. You see get access returns a float value, 0 or a -1 to 1. And what this means is what's going on in this line is you're actually getting into Unity's input system. If you go to Edit, Project Settings, Input, you see Axes, Horizontal, you can see its name is horizontal, negative button is left, positive is right, alternate is A, and other alternate is D. And there's gravity and dead and other stuff, right? So what's happening here is when you press A or D, it's actually changing a float value in Unity's input system to be -1 or 1, depending which way you're going. And this returns the value of that. So if you ever have like a racing car game and you press D and the wheels turn right, the game isn't just listening to what you're typing, to what you're doing. And this get axis acts as a -1 to 1 value of range for 2 keys to be able to transition to. So if I press D and then let go, it'll fall back slowly, not slowly, but it won't just snap to 0. There's actually settings to do that. There's snap right here, right? So it'll snap, and it'll go back to 0. If I press A, it'll go -1. And so I'm multiplying my direction by this. So if we're positive, meaning we're pressing D, the direction that we're setting this to is positive, right? If we are pressing A, it returns negative, which will reverse its direction. And this is just defining the direction we're trying to push the ball into. So this isn't complete yet, though. We can just move in one axis now. Let's move in both axes. So we're going to specify the direction again, but we're going to add, right? So you can't multiply vectors together because it's like, how do you multiply an xyz times an xyz? Yes, you may sometimes want to do x times x, y times y, z times z, but that's not actually done a whole lot in vector manipulation, and so it's not natively built in. And it really isn't common. Like, I've rarely ever used that. What's more common is to add vectors together, which actually performs more of what people are looking for. If you add vector right and you add vector up to it as an example, you're going to get, let's see, vector right is 1, 0, 0, and up is 0, 1, 0. So you're going to get 1, 1, 0, which is a new direction in space. And that works out fine. So that's what we're going to do. We have a right direction. Let's get the forward direction, the vertical portion. We don't want to go up because that's just like flying up into the air. We want to roll along that plane. So we're going to go ahead and get input again, except this time we're going to get the vertical axis. And this corresponds to W and S, W being positive, S being negative. And this, in general, just defines the direction our ball is going to roll into. At this point, our direction is there. So what we're going to do is we're going to take our direction and we're going to multiply it by how much force we really want. Because you can multiply a vector by a linear constant. You can multiply it by a constant, right? Because it makes sense. You multiply x times the constant, y times the constant, z times the constant. It makes sense. Just not another vector. You can, though. Let me show you real quick, just so you don't feel like you just can't. So look at this. New vector 3, and we can take, it's going to look kind of weird, times x, and then multiply by vector 3 dot like right, and then x, and there's a new x component of this new vector. So you can kind of like do it like that. Reference new other vectors, multiply their values together if you need to. Like I said, it's not very common. Don't worry too much about that. Alright, so we have our direction, and it's actually based off our input now. We can play our game. We have our direction, and we have our force multiplied, which means we can control how fast, or rather how much force is applied to our object, right? So yeah, let's go ahead and see if that worked. It's compiling. We'll check our sphere to make sure. Yep, force is 5. Click play. And press D, A, D again to level back out, S, A, or W, and there we go. I have full control. And you can see I passed through the pickups because they are not, their colliders are not set to actually collide, they're set to trigger, which means you can go right through them. You can also roll yourself right off the edge. But yes, you have now a moving sphere you can control. In effect, this is a game. Not a very fun one. We need to add a little bit more, but it's a game. Alright. And you can increase the move force if you want. Just throw it up really high and you'll see that it's a lot more responsive and we fly off a lot easier. So yeah, we just define a new direction, got a direction based off a global right, and multiplied by our input. Did that for the other axes as well, and then multiply by how much force we want, and add it to our rigid body in the fixed update, which is the physics time step, and there we are. Now we can do a couple more things though. There's a couple problems. I mean, the very first problem obviously was that our pickups didn't do anything when we touched them. That's kind of a problem. Second problem might be you don't want your player to fall off. That's another problem we're going to have to fix. And the third problem is this. Let me take my camera. I'm going to move it over here. And I'm just going to rotate it to face the area again. And I'm going to click play. And I'm just going to press W, which initially had pushed our ball away from us. And obviously you can see where this is going. Press W now. We come towards the camera, and S actually makes us go backwards, well, forwards looking at the camera. And if you press right, you actually go left, everything's backwards, right? Because our perspective is backwards. You see on the axis here, our camera's facing the opposite way. How can we fix this? And it's actually not that bad. You may be like, well, I don't know how to do vector manipulation or whatever he was saying. Well, just hear me out. We should go ahead and add a public, meaning Unity accessible, game object, and this is just a reference to another object in the scene, and just say camera. In fact, let me just take it a step further. We don't need the global game object. We want the camera's transform value, its position, rotation, and scale. We want that. Here you go, camera trans, right? And we'll set this in Unity. And what this does is, it's a reference to the transform object, to a transform object rather. And you'll see here it says none, and we've had that before. I told you that you need to have something there, otherwise it'll be null unless you don't use it or if you get it at runtime. But we aren't. We need something there. We're going to have to use this camera transform. So go ahead and just grab the camera. You see it turns into a plus because the camera has that transform on it. And it's set. It's good to go. So how can we make this a little bit better? And the way we're going to do it is instead of using the global, right, take your camera transform, and it's going to introduce a new concept, right? And it looks very similar to what we just had, except now we just replace vector 3 with camera trans. And it turns out every transform has a forward, right, and up direction. And we saw that when they were rotating. We saw those, right, in here. And it's those axes, right, relational to that object. So if we were to reference this object's up, we would get that direction in space. But we're actually referencing this camera. So we're going to get that direction and this direction instead of the global, this direction and this direction. And what that's going to do is now, make sure it's saved, now it's actually going to be relative to our camera. So now even though I had moved the camera, look, I press W and it goes forward and S goes backwards and right goes right and left goes left. It's perfect. You're like, well, I don't know. Okay, so just hear me out. Watch this. I'm going to move it into global so I don't have to constrain to the axes of the camera. I'm going to put on an angle now. Look at this. Right? I'll just look up. Nice broad angle. I'm going to press W. And look at that. It's relational to your camera. It's relative. And this is kind of like what you get with like you're driving a car game, a racing game, or you press forward for your character to move forward in the direction of the camera, right? This is how that's done. They get a reference to the camera and they see what direction it's looking in. Now this is technically not entirely perfect, and the reason why is kind of what I showed you. If you look at the camera, not in global but in local space, get the Z and the X, the forward and the right vectors. And that's great, but they're not flat. We're moving along a flat plane, but we're adding force along these vectors. So we're actually technically adding force downwards onto our sphere. And you may not notice this with this simple of a game, and that's not a big deal. You can see our right vector is actually technically parallel with our plane. It's flat. but our z is not. And with this simple of a game, it doesn't matter a whole lot. With a non-super big like physics game, like maybe Kerbal, it would matter. In this, it does not. If you want to know a solution for that, it can be a little complicated, but I'll show you anyways. Go ahead and take a look. We're going to find our direction is actually going to be equal to, I'm going to replace this line up here. This is about to be replaced. So this is what this line is going to be. I'm just kind of working down here. So what we're going to do is I'm going to use a function called vector3, and I'm going to project onto a plane. And this is kind of a complex function. You kind of have to use your imagination a bit here of how this works. And I know I'm introducing a lot of things right now, so just kind of bear with me. Don't worry, this is not necessary to program. This is not necessary to create a game. This is just a solution to some problems in game development. That's really all this is. So, what this does is it references a static function within the vector3 class, and it's called project onto a plane. And then effectively, given this plane here, this one, I mean, it's normal. Its up axis is up, right? And this is the up. This is kind of like the surface we want to move along, right? We want our object to move laterally along and roll along this surface. But you see our z is actually not on this same plane as those two axes. So what we do is we take this direction and we tell it, flatten yourself, like just straight down, like kind of like this, straight down onto those two axes of this plane, the lateral planes. Just kind of flatten yourself down onto those axes and kind of eliminate the downward trend we have and just make it flat in that direction. So it maintains its forward direction. It loses its downward or upward, kind of esque to it. And that's really all this does. I tell it, hey, get rid of all the upward or downward inside of this direction. And it's actually forward, not right. And the trick, though, is when this returns the new direction, it will actually be shorter than what the direction should be. The length of the vector will actually be this much instead of about that much. It'll only be about like 75 to 80% of the full vector. Its length will not be 1. And that will kind of, sorry about that, that will kind of interfere with our multiplication, because if our direction is not a length of 1, it'll multiply our force by the new length. So if our length is actually 2, our force will be doubled. And we don't really want that. We want a vector length of 1, or magnitude of 1. So normalizing divides each component of the vector to eventually make the vector a length of 1. And it just does it really quick. So that's all I do, and this effectively makes it more of a direction than a point in space. If you don't know what I'm talking about, it's not a big deal. This is just mathematics, vector mathematics. You can Google it, look it up, look what normalizing does, all that kind of fun stuff. We're looking on just how to get a game started and how to kind of script in Unity. So this is a solution to the problem, and this, I'm going to replace it. I'm going to replace that. Now, our right axis here, or our oh man, what did I mess up here? Okay, so I'm just going to switch these. I kind of got it backwards in my head there. No problem. Happens all the time in programming. Vertical. Yeah. Okay. This is our horizontal on the right axis. Our right axis on the camera is actually parallel, so we're not going to worry about that one. That one's going to be on the lateral planes our sphere should be moving. So we're not worried about that. So let's just run this, and it should not look any different than it did before. Honestly, it should look the exact same. Now, if you're to actually like debug the velocity or the forces being applied to the sphere, you would see that it's not correct. At least it wasn't correct. Oh man, I keep doing that. I'm sorry. But now it's perfect. It's correctly calculated at this point, and this isn't super necessary. This is just being picky. This is just making sure that this is like making sure it's a purely physics-based game, making sure it's correctly physics calculated. And we don't need to do that, but we did, just to show you kind of the kind of stuff you can do. So we have our ball rolling around, and we even have a relation to our camera. What if we made our camera, well, what if we made it move? What if we were able to rotate our camera? And this is going to kind of introduce a new concept in here. I'm going to create an empty one, and I'm going to call it camera anchor. And we'll need to reset it back to 0 to the center of the screen, or center of the world rather. And you can actually do some stuff over here, right? So I can actually pick up this camera. You'll see it comes like flashing for each object in there. So what just happened? I parented the camera anchor to the main camera. And what that does is the main camera is now inheriting or absorbing or using all of the anchor's values. So if I select the camera anchor and move it, look at our camera, it's moving too. If you rotate, look at that. Our camera rotates with it, but it maintains its offset. It maintains its values that are slightly different. So I can still select the camera, fix its angle. Maybe it's too high, maybe it's too low, kind of whatever. It's no problem. So, why do we do this? Well, we might want a camera that just kind of looks around our little area here. How might we do that? Well, I created an anchor, and here's why. Switch to rotate tool for me, and on this yellow axis, the y-axis, rotate it. Look what happens. Our camera effectively orbits along the y-axis up and down, the vector 3 dot up, around our scene, around our little play area. So what if we could listen to the mouse input and rotate this parent around that axis, just like we did in a rotator script, or similarly, and effectively rotate our camera as well. Let's do it. Create new C# script, camera rotator, name whatever you like. Okay, we're going to need another float variable to kind of multiply things, rotate amount. This is kind of like a sensitivity thing. Basically what this is the maximum number of degrees at max input of rotation. So we may need it a bit higher. I'm just not sure yet. Okay, now we're going to do every update. I'm going to save this and turn back to Unity for a second. I'm going to go ahead and add this script right now. Camera rotator. Camera mount 5, and it's on the anchor. On the anchor, because we want to rotate the anchor to effectively create an orbit for the camera around the scene. Right? And something else I'm going to do, actually, you know what? I'm not going to worry about it. I was going to reset the position and angles of the camera, but it's fine. We don't have to worry about that. So it's very simple. Transform.rotate, just like we did before. We are definitely going to be on the up axis. This is not going to be a generalized script. This is specifically to rotate the camera along the y-axis around the scene. This is more of a game-dependent script, whereas the rotator script is not. We're going to rotate along the up by the rotate amount, but not constantly. We need to get, well, input. And similarly, it's an axis. What axis is it? Mouse X. Just like that. So there's actually two axes defined for your mouse, X and Y. Obviously, moving left and right on your mouse will trigger the mouse X axis. And that will scale how we move along the upward axis, so rotating around, up to a maximum speed of a rotate amount based off our input. And that will work. I don't remember one thing, and that is some axes for the mouse get reversed in Unity, and I'm not sure which one it is, but it looks like, yep, see, it's reversed. I move right, and the camera moves left. But look, this is what you can kind of do, and this is a value of 5, and it's pretty sensitive. And since we had already created a relationship between how our sphere moves, relational to the camera, even if you rotate around, you move backwards, your sphere will rotate towards you. If you hold up as you move, like you can, it may feel natural now because you games are like that. You move your camera, and the object, the player, moves in relation to the camera. So we're gonna have to actually, you could technically just go ahead and here and negate this, but I don't like negative numbers as my variable, so I'm gonna actually negate the input. Just because I view the input as already negated. You could also fix this by going to project settings, input, finding the mouse X, and you can actually invert it. And that will do the same exact thing. So there's tons of ways to achieve it. This will work. Now when you play with it inverted, you move left, the camera moves left. Move right, the camera moves right. So yes, now we have a fully moving camera. You can look around and everything. So yeah. It's kind of weird actually. This is not an ideal camera setup, I'll tell you that right now, but it's basic enough that it should work. At least because it's a nice viewpoint. Okay, so there's only a couple more things we need to add, right? So we've been kind of adding a couple more features and a couple more things, but the original game is not being finished right now, so we haven't actually made any gameplay changing stuff. We still fly through our pickups, and that's not really ideal. They serve a purpose, right? We want them to serve a purpose. So what we're going to do is something really kind of basic, and we're just going to delete them when we touch them, right? I know it sounds kind of dumb, but you can reorder these up here by the way, dragging them around. We're going to listen for when our sphere, which the script we currently have, which the player manager is attached to, we're going to listen for when we collide with something, and we will effectively just delete the other object. The problem here, and the one thing I want to caveat real quick, is when we detect collision for everything. So if we just delete whatever we touched, we're going to delete the ground. And we don't want to do that. So we need to do something. We need to be able to differentiate between the ground and pickup objects. Now, yes, you could say, well, the ground is named ground and the pickup objects are named pickup. But that's not a really great idea, because what if you have many pickup objects all named different things? Or the ground is not named ground, right? You might, if you change them, if you change names, you might have to go in your script, change the hard-coded values, and just make things a little more just hard, honestly. That's the hardest. It's just pointless. It just makes it harder on yourself. Unity has stuff for this, and this thing that's really easy to use is tags. And they're right up here underneath the game object. And I'm actually, instead of choosing pickup 2, I'm going to go back to our prefab, because we want all of the prefabs to have this new value. And I'm going to click the tag. You can see there's some stuff here. There's a respawn, finish, editor only, main camera, player, game controller. And these are mainly used with trigger colliders, and that's what we have. We're going to add a tag for the pickup objects, right? So we're just going to go pickup, and it's added. Now this is a tag and layer, so we're no longer actually selecting our prefab. Let's go and reselect the prefab, go here, pickup. Okay, but how do we detect collision? How do we know that the tag is pickup? And how do we delete? It's not too bad. Okay, now on the pickup objects, it is a trigger collider, not a normal collision. It's going to be a trigger collider. They actually are two separate functions. The other one is on collision, like that. And you don't have to keep deleting private like I do. I just personally have always programmed Unity without it, so it just kind of is old habit. Feel free to keep it. It doesn't change anything. It's all personal preference. So this one gets called for when the sphere actually hit another collider, like the ground. This one is called when the sphere enters an area defined by a collider, but is actually not hitting the collider, it is just entering the collider. It doesn't actually get stopped, or its velocity is not changed, etc. Which is the one we want, because our pickups are not actual collisions, they are just triggers. So, how do we access the tag? Well, we do get past what collider we're actually entering. So maybe from that we can actually get the tag. And it turns out that is such a thing. So use other, and look, tag. You can easily access it. You don't have to go up to the game object. You don't have to go to the transform. It's already right there, because it's part of the mono behavior it is attached to. And then just compare it with the equals to pickup. right? And if this feels wrong to you, hard coding this, I said it was bad to hard code, it is. Make a variable, string, and pickup tag, and set it to a default pickup. And this way, what this will do, change this to a new variable to check for. What this will do is in Unity here, on your sphere object, you can actually specify, okay, well, we changed the name, we changed the tag of the pickup tags to something else. You can change it here now. You don't even have to go into the script. It makes it more user-friendly. Okay, so it was the pickup tag, so let's go ahead and just destroy it. Let's make it disappear. So you can see that it takes an object to destroy. And if you just say other, it won't give you an issue. And the reason for this is you can destroy objects, any object, meaning you can destroy a component off of an object. I could destroy this script off of the sphere. And we don't want to just destroy the collider, we actually want to destroy the entire game object out of the scene. This will completely remove the entire game object and all of its components out of the scene, no longer running, it is gone. Okay? So yeah, let's go and switch back. See this update. And now, let's make sure our pickup object actually have that pickup tag it should have because the prefab was changed. Click play. And go and just go touch one. And bam, and bam. Look at that, you're picking up objects. And you can see on the left that the scene is getting smaller. That's literally because it's being removed from the scene. See, there's no more pickups. And then when you exit, everything comes back to the way it was before you entered play mode. It's very nice, very kind of convenient. It can be frustrating when you change something and you want it to persist, but there are ways around that. So yeah, we can pick up our pickups. So, where do we go from here? From here on out, we have a goal. The goal of the game is to pick up all the objects. Every game needs a goal, right? What are you doing if you don't have a goal? Build the biggest rocket, get to the end of the game, play the career, defeat the bad guys, pick up all the pickups. But, I mean, it doesn't feel very rewarding, does it? Like, how many points do we get? Do we win if we get all of them? Well, there's stuff we can add. So from this point on, you're really just adding, you're decorating. You have the goal, you have the functions of your game working. You just really got to add a little bit of well, not structure necessarily, but some decoration, if you will. So I'm going to add some walls, because I don't want people just flying off out of control. Because maybe I want to make the sphere a lot more sensitive, a lot more, what am I trying to say here? A lot more responsive. There we go. So you may see it just snapped across, and that's just me holding control and moving this along. And I can snap it right to the edge right here. And I'm just going to use a couple of manipulation tools, scale it out. You can again hold control and you can get it precise. Okay, and so there we go. There's one wall. I'm going to do a little trick I know. And this is to create an empty object. I'm going to call it an anchor, just so I know. It's not going to last very long in the scene. We're just going to use it real quick. Zero it out to 0, right? Parent the cube that we just created, which is a wall, to it, making the anchor the parent. So now if we rotate the parent, that rotates with us. And what we're going to do is we're going to duplicate the wall. We're going to take this wall, drag it out. And now rotate the anchor by 90 degrees on the y-axis. And you can see we've effectively, easily positioned, scaled, and moved a new wall. So duplicate that one, move that one out. It doesn't matter which one you move out, just move one of them out. Click and drag, hold control to snap, duplicate, and drag out. And you can see we're just building our, oh my gosh, I'm having trouble, aren't I? We're having trouble, or not having trouble, we are effectively building a wall, an arena. And then once you have your last one, just drag the last one out, and then delete the anchor. And you see we have all 4 walls here, and we can no longer fall out of our scene. They all have box colliders, and they're all static, so they're not going to fall or move or rotate. They're just going to be like static walls in the world. and go ahead and play. And now, see? Can't fall out anymore. Pretty nice, huh? Alright. So we have a nice arena, and because I don't like all these different objects here, I'm going to kind of organize. Create a new one. This is going to be our arena. I'm going to zero it out to 0 because that's where the arena is. It's in the center of the world. I'm going to grab the walls, put them inside of the arena object just like that. I'm going to grab the ground, also put it in the arena object, and minimize. And now look, our arena object is all one beautiful piece that we can rotate at our leisure, whatever we feel like. And you can do that for the pickup objects as well. I probably will, just for, keep things clean, organized. It's good to keep things organized in your scene, otherwise you won't know what was what or what it does. You see, we kind of know. We know that's our sun. We know that's our, well, actually that's not even correct. I almost named that our player. We know it's a camera anchor. That's the arena. It's pretty simple. Okay. So, let's add something new. We can't fall out. We have a nice rotating camera. The ball moves according to the camera, not according to the world. That's some really nice features. And if you look at our scripts, they're really not that long. Look, 36 lines in total. Most of this is brackets, and it's nothing too bad. There's a little, this was complicated, but that wasn't even necessary. So it's really simple to be able to create variables with code, play with them, adjust them, like increase our move force, make it more responsive, play with it while it's playing. This is a great way to view how scope works and how, how programming can be interacted with on a visual perspective. It's really nice. You don't have to worry about all the, how do I compile this into, its binary files, how to make an exe out of this. This is a great way to play with physical objects in a virtual space and to really kind of get a feel for how coding can affect things, because really the objects in the scene are just visual representations of objects we normally create in code. Like if I had a student class that was defined by its grade and, I don't know, the parents' names, those are all variables inside of that class. Well, it's the same thing here in Unity, right? I have variables defining what the player manager means, and I can visualize those things and make the virtual world change based off these variables, which is really nifty. And, oh, by the way, you can create your own function. You don't have to choose one of theirs. Create your own. Call it from something else. Look at that. It's programming. Everything's here. Everything we have had in other languages is still here. This is just mostly the basics to get this is kind of a fancy game, honestly. I mean, we got some, like I said, the relational between the camera and the player is actually kind of a big deal. A lot of games have issues with that kind of stuff. A lot of the small games anyways, indie games. So, but let's make this game even nicer. Let's just add a couple finishing touches here. Let's just add a couple more stuff to make it a little more nice and a little more fun, right? So, we're actually going to start doing something on a 2D, what am I trying to say here? Workflow, right? So this has all been 3D, and we could keep it in 3D, but let's go ahead and work in 2D. Now there's an option for this right here, 2D, and you're like, okay, I did that, and everything is weird, and I don't understand, and it's okay. Click 2D again, get out of it. We're not going to use that. That's for workflows that are entirely in 2D. Fully 2D games will use that feature, but even they may stick in 3D, actually, because it's actually easier to see things or get closer to things, and it just kind of depends. But that's what that's for. So we're actually not going to use that. What we are going to use is something called a canvas. And this is where we get into user interfaces with Unity. And there's its own category. There's a lot of options. There's a lot of settings. There's a lot of customization. We're going to stick to the bare bone basics, okay? This UI is a complicated thing, especially in Unity, especially in game engines, because of all the different effects you can do. We're just going to add some text to the top left corner of our screen that displays how many pickups we have picked up. Alright, it's very basic. And if you want to get more advanced, feel free. This is a deep rabbit hole, I will warn you. But for now, we are just going to keep to the basics. UI, text. This is going to see, you're going to see a canvas get created. That's okay. A canvas is required. Let me say that one more time. A canvas is required. To show you what I mean, you'll see the new text here. The canvas is huge, by the way. So press F to focus out to it, right? And you see our arena is just down there. So click on the arena. If you need to focus back in, press F, and you'll be back here. Canvas, to go to the canvas. So the reason why this is so big is mainly because this canvas is a screen space canvas. And that may mean nothing to you, but what that means is the rectangle you're seeing is my screen. Any text in relation to this rectangle is in relation to my screen. For example, this text down here, I'm going to move it up to the center. It's near the center of my screen. Look at this. There it is. It's near the center of my screen. It is relational to your screen. So, if it's over here, you won't see it. It's not there or there. If it's just on the edge, you'll see it. So something to keep in mind with the UI that's really difficult to do is resolution differences, especially with games. I mean, games change resolutions. People play different resolutions. It's kind of hard to keep things visual and keep things clean. But there are some tools for this. There's anchors and pivots and a lot of more complicated stuff. What I want you to do, and this is going to be really nice and simple, is I want you to press Control, I'm sorry, not Control, Alt, and Shift. Just like these two say, press both Shift and Alt, not Shift, Shift and Alt, and see this top left one here? Go ahead and click that, and you'll see this move. So what that effectively does is you'll see some other icons up here, and right, if you get close to the icons, stay the same size, just keep that in mind. So you'll see these four little, like, I don't know, triangles. They define the anchor of the UI on the canvas, and we don't want to get into this. This is complicated. This gets weird with how resolutions change. What we want is just text in the top left, and that's what we have. By setting its anchor up there, it'll stay in the top left even if our resolution changes, like this. See how it's staying in the top left? And even if I change this way, see how it's adjusting? That's what we want. We want it to stay in the top left. Now we don't want it to be black, so I'm going to change it to like a nice white because our ground is dark. Okay, and there's other options, font options. If you want to change it to bold, italic, if you load in different fonts, you can do that. Font size, size spacing, rich text is like HTML markup. It doesn't support a whole lot, but it does support emoticons and colors, as you see. You know, alignment, you know, kind of like your own default word processor. So the cool thing though is best fit. Best fit's really nifty because it'll actually change the font size dynamically to how big you have your element. And your element is defined by its transform. You see this transform is not just rotation, position, and scale. It's a little more complicated. Don't worry too much about it. Honestly, the width and the height are important to us right now. You change that, you see it changing over there. Change my height, you'll see the text getting bigger. That's important. If you want text bigger, that's one way to do it, but this won't change if best fit's off. See how it's back to normal size? With best fit on, it'll try to fit the text as best as possible in the container it's in, which is defined by the width and height. The position just offsets it from its anchor. This is why things get complicated. See, your anchors are here. There's also pivots. You do have rotation and scale as well, so you can actually kind of warp things. So you can rotate in 3D space or 2D text. However, it will just look scrunched up. It won't actually look 3D rotated. So keep that in mind. In here, it looks 3D rotated in perspective because that's the camera mode. On here, it's rendered as orthographic, which is just flat. There is no depth. So effectively, that is useless. However, why is it not letting me? Huh. That's kind of weird. It's not letting me specify the exact value there. But there's an easy way to fix that. Reset, and then control, or not control, alt and shift, increase the width, increase the height, oh my gosh, the height. And the reason why it's not getting any bigger is because you specify the max width, which is the max font size, to not get any bigger than that. If you get any bigger, it just like starts slowing down the system because it's rendering more letters at higher resolution and whatnot, and just don't worry about that. So, great, we have text, but it says new text, and that is effectively useless, isn't it? Alright, so we need to kind of fix this, and how are we going to do that? We're going to go to scripts, we're going to create one more script. So go to C# script, this is going to be pickup. Wow, switched languages, didn't I? No wonder why my 0 wasn't working. Pickup counter. Okay. Now, it won't be like this. We're not going to use these methods. It will be model behavior because it's going to be attached to that text object. And because it's attached to a UI object, you actually have to include one more reference. And it's actually the UI. And the reason why that is some games don't use UI, and the UI includes a lot of functions, classes, and etc. And you know, you don't need it all the time. Like for example, we didn't need it in our 3 other classes. This is the only one that actually did. Actually, we are going to use awake. Take it back. Sorry. But there we are. And the reason why we're going to use awake is because we're going to need to get the text object, the text component of the same object we are on. For example, text object, add component, pickup counter. So now it's on the same object as the text component, and we're going to get it. Now you can't get this text without using the UI reference up here. So make sure you add that, otherwise you won't be able to get your reference. And we're going to do it just like I did with the rigid body. You can set it up, oh I spelled counter wrong. You can set it up to actually just drag in the editor as a public reference. Again, just personal preference. And do the same exact thing. You're going to get the text. And the main thing that we're going to do with this is the counter text reference now has a text variable that you can set the text of the text UI. I'm tired of saying text. Okay, so how are we going to count though? What we're going to do, there's a couple different ways we could do this. We could give a reference of this instance of the script to the sphere, to the player manager, and have it adjust it for us. Or we can just have a static variable, and I don't think that's such a bad idea. So I'm going to create a public static int, and this is going to be our pickup count. It's going to default to 0. It's going to start at 0. And every time you start your program, it's going to be 0. And it's because it's static, the instance of this class is not going to actually have its own instance of that variable. It's going to share the same memory as any other instance of a pickup counter that may exist. Fortunately, we're only going to have one, but the reason why it's static is so that in our player manager, when we actually run into an object, we can actually go to the pickup counter and statically tell it the pickup count should increase by 1 when we run into an object, right? So this makes sure that we don't actually need a reference at all because it's static. It's globally accessible because it's public and it's static. So we don't need the actual object of the pickup counter. We just need the class qualifier, and that's what we did. So great, we have our text. We have it actually counting our pickups now. Let's just display it. And the way we're going to do that is every update. And this is not an optimized way to do it. This is just a way to do it. This is not how it should be done. It's just a simple way. We're going to set our counter text dot text equal to pickups colon, and then we're gonna add on the pickup count of how many we've actually picked up. And there we go. Let's check it out, shall we? And don't worry about new text because as soon as we start the game, that'll be fixed. Look at that. Pickups 0. We have our scripts running, no errors, and we go touch one. Look at that. Pretty nice, right? So this is one way you can count things. Kind of use a static variable. You can most of the time you're probably actually going to use the reference method. You're going to use a reference to this class and then tell the class, okay, increment increment the variable. And so one way that might be done is actually public static method increment count, right? And you're like, okay, well, how's this going to work? Well, what we're going to do is we're going to take the public modifier off of this. We're going to make this static, right? So this means that there's only one reference to this text available for this entire blueprint, right? So any instance of this is always going to have one reference, and that one reference is set up on awake. Now this would not be ideal if you had more than one of these, because you would have all of them running this awake method, all of them setting it, and all of them getting their own text component, which means by the end of the day your text component could have been the last one that ran, which doesn't make sense, right? But for us, right, so we only have one of these. We only have one that's going to run, so it's no problem. We only have one. We know for sure this is only going to run once, and we know for sure it's going to get the correct one. We could even do the same thing as we did before and require the text component to be in there, right? We can require that as well, just to make sure this never errors out, just by some accidental mistake. And then instead of updating every frame, why don't we just update it when it actually updates? And we can combine this all into one thing, just like that. That's right, so we don't need this anymore. Get rid of that. And you'll see we have an error over here now. See, it doesn't work. But we do have a new static method called increment count. We'll just invoke that method instead. And that'll effectively get our static reference, because currently this is an instance scope. But instances always have access to the static variables, so it's able to set the static reference to the text, which is in the scene, to the text. You can have an in-scene reference as static, but it can only be one static per entire class, no matter how many instances you have. So if you're more confused about how static works, just look it up. Again, this may not be the ideal way to do this. This is just a way that I'm kind of working with as I work with you right now. And that way, what this means is that now when we ever use this little tiny API pickup counter, we don't have to worry about what variable it is or plus plus or anything like that. We just know that there's a way to increment the count, and so we do. And this effectively adds one before it creates the text, right? So it adds one first, and then it creates the string, and then assigns it to the text of the text component. And this will effectively do the same thing. It's just a little more optimized. And you'll see that it's new text right now, and that's kind of an issue, right? But as soon as we touch one, we're good to go. So yeah, just keep that in mind. See kind of a little bug there. We may not want to say new text right away. Maybe we want it to have instructions. So you can either just set it here, right? There's some instructions. You could set it in the awake method. You could set it, set the text component here, and it would work. There's no problem either way you do it. It's kind of nice to see it in the scene though, because you kind of get a preview of what it's going to look like. And I'm just going to extend this out before you play, which is kind of nice. It's kind of good to get an idea of what it's going to look like. And there we go. It obviously resets it. And now, see, it's not running every frame, which is good. Saves a little bit of processing power, just a little. But when you're making a really complex game or stuff that uses a lot of like APIs or just complex mathematics, it matters. Those small little calculations matter. All programmers should be concerned about a little bit of efficiency. Okay, so great, we can count now, but let's just add one more thing, and let's go ahead and specify, let's just do one more thing, and it's going to be like a you win message, and we're just going to honestly replace this text with you win. So display win, right? And it's just going to change the counter text to equal you win. Very simple. But how do we know we won? And we're going to effectively have we're going to specify that we we are no longer able to collide with any more objects. And the only way to do that is to detect if there's any more objects in the scene. And there's a couple of different ways to do this. The easiest way would probably to tell the counter, say, hey, there's this many objects in the scene. That's one way. I'm going to do a less efficient way. And the way you can do that is game object, capital game object, by the way, to get the capital class, the actual class. And you can find objects with a tag. And it's going to return a game object array. And then you specify the tag. Right? This is very expensive, though. I will warn you, this is expensive. This is not a good way to do it. It is a way. Remaining objects. Right? If tell you what, we might have to move this actually before we destroy any of the objects, because I'm not sure how it's going to behave since we're about to destroy some objects. So if the remaining objects dot length is equal to 1, because there's one left, right? We haven't actually destroyed it yet. There's one left. Then pickup counter display win, because we're about to win. Otherwise, go ahead and just increment the counter for us, right? There we go. And now we're kind of defining our branching behavior, and then just destroy the object afterwards. Destroy the pickup object. So this is kind of like a way to just kind of handle different behavior based off game state. It's kind of the beginning of our game state. And we're going to see this kind of go into effect right now. So touch objects to pick them up. Our camera's working. You know, it's kind of bothering me now because I'm not sure if I want the camera to rotate left or right with my mouse. It's kind of weird. It'll work for now. Anyways, touch it. You see our pickup's working, right? And then, so each time I pick one, it's actually scanning the entire scene for any pickup objects, which can be really expensive. But look, it no longer detected any. Well, actually, it only found one left, and it knew that one was about to be destroyed, so we won. So yes, this is a way to change the game state, change content, move things around, and just kind of develop your kind of gameplay. And obviously you can start adding effects. Maybe you want particle effects, explosions. Maybe you want the cubes to burst into fire when you touch them. You know, you just kind of keep expanding out from here. The main point is that the scripting is mainly built off events. And you kind of develop around that. You kind of just have a goal, like, okay, what do I want to do? Okay, I want the camera to orbit around my arena. So how can I do that? Well, I can have an anchor in the middle that will rotate, and which will forcefully rotate my camera around as well. That's one way. Another way is you could do, there's some vector functions to orbit a position around another position. Those exist. Probably more expensive, honestly, than just doing the parent method. So you just define what you want and you go for it. So really at this point, I'm going to say that we're done with our simple rolling game. It's playable. It's a playing game, you know. And so I'm going to leave it at that, I think. If there's any questions, feel free to leave a comment. Feel free to message me. Feel free to contact me any way you feel, if you can find any way. Anyways, and I hope this helped at all. I hope this was a good intro for Unity. I hope that after this you feel like you could sit down and not only copy this, but go ahead and, you know, start modifying it to your own. Don't forget that Unity has plenty of tutorials online. There are plenty of other users have created tutorials for Unity, plenty of them. There are plenty of C# tutorials out there. If you'd like me specifically to do one of them, I'd be honored to, since this is technically my first ever tutorial in any way, which is kind of cool. Yeah, honestly, just let me know. I really enjoy this stuff. I play in Unity in my free time all the time. I know this video's been significantly long, and I'm sorry for that. Hopefully I wrap it up here. And yeah, if there's any topics I covered that were just super confusing, don't be afraid to ask me. I understand everything I wrote today. Some things I don't, and I will hopefully learn as you do if you ask about them. But otherwise than that, you've got yourself a working game if you do like this. And yeah, I wish you guys the best of luck, and show me what you got.